Okay, so what we need to do is finish discussing the list, which the last thing here is number 4, multiplicity of zeros. Once that's done, we'll just dive into some graphs and see how it goes. Okay, so the idea with multiplicity of zeros has to do with how often a factor or a zero occurs. And when you look at multiplicity, we'll talk about it as being even or odd multiplicity. And it has to relate to the exponent on the factor. And the key really for graphing is the even multiplicity, or those factors that have even exponents, because that has an effect on the graph. Odd doesn't. And the effect actually, some we'll talk about probably, well, will be more obvious when we start doing a graph, and I'll discuss it here with you guys for a second. But for starters, just look at the examples. And what you see here is exponent 2, that's an even multiplicity. Exponent 1, that's an odd multiplicity. This one also has an exponent 1. That's an odd multiplicity. Okay. This is 3, 1, and another one over here is 1. Those are all odd multiplicities. The only one that really affects our graphing is even. And what will happen is you're running your graph through the intercepts. You know, normally when you do a graph and you go through an x-intercept, what you do is you go right through the axis. So let's imagine I've got an intercept right here. And I draw right through. When you have an intercept, which comes from a zero or a factor with even multiplicity, what the graph will do at that spot is it'll bounce right off of it. And it won't go through. And you'll have to catch this, because if you don't, you're going to draw your graph incorrectly, and really, because of all the other stuff on your list, it'll be kind of obvious that, okay, I missed the multiplicity, or something's not right, because you're not going to be able to draw it the way you want to draw it. Okay, so the rules are down there for how you know, again, the significance, or the key here for us is we're really looking for those even, those ones that cause the bounce. So just for a little practice, let's do a little factoring first and check out the multiplicity concept quick, then we'll get into some graphs. So let's just start by factoring these two problems. And just like, you know, good old-fashioned factoring, if you look at the first example there, it looks like 4 terms is going to be factoring by grouping. So start out with factoring by grouping. Okay, so right here they recognize that became the difference of squares. But really, because I have the same factor twice, I'm going to write like that. Now if I talk about the multiplicity of factors, this factor has, I'm sorry, that's a mistake there, whoops. This factor has an even multiplicity, because of that being 2. This one has an odd multiplicity because of that being 1. This is the one I'd be concerned with. That's the one that's going to cause the graph to change direction right at the intercept and not go through the axis. Now, checking this one out, x squared, take out x squared. A little bit more trial and error factoring. Then if I ask the question about multiplicity in this case, you know, again, checking out your exponents on your factors, squared, 1, 1. Even, odd, odd. Even is the one I'm concerned with. That's the one that's going to cause some kind of issue with graphing. Okay, so you know you'll have to take your function and start out the problem, which we're going to do in a second. Get them factored, and then start generating a list of all this stuff, and we'll see the list kind of develop here as we go through our graphing problem, and then see what you can do with the graph. See how accurate a graph you can do by hand. Okay, so here's our first example. Now this one's already factored, so it's in a factored form, so really we can dive right in with the intercepts. What I'm going to do before I do that is I'm going to jot down a little space in the space here. 0. What are the zeros? The zeros here are 1, -1, and 2. So zeros are like solutions, you know, but you don't write x equals. Kind of weird, like why is it such a big difference? But we just write them as the numbers. And then zeros can be translated into x-intercepts. X-intercepts and y-intercepts are coordinates, so don't write them down as just the number, because now you're writing it as a 0, right? So again, a little thing about how we write it. In this one, if you say, where is the y-intercept? Well, if you just plug in 0, for all the x's, you'd have -1 times 1 times -2, which means you got a y-intercept That's 2. Now, to really answer the behavior question, because it's a factored version of the function, you have to think about if it was multiplied out, what would be the degree, and what would be the lead coefficient? And that you can figure out by doing x times x times x is x to the third. So in other words, it's got a positive lead coefficient and an odd degree, which means it will rise on the right and it will fall on the left. So just some expectation. Any zeros with even multiplicity, well, if you look at the zeros or you look at the factors, they all have exponent 1, so this would be a no. And possible extrema is 1 less than a degree, so this being degree 3, I'm expecting 2 changes in direction, 2 extrema. Okay. Well, now it's time to get all your intercepts, put it on the graph, and just see what happens. So I start plotting my intercepts, and I've got negative 1, 1, 2, and a y-intercept of 2. And if you think about the behavior, the fact that it's supposed to rise right and fall left, there's not much mystery as to what the graph does, right? Now, one thing about graphing is when you have some space in between intercepts, how far, should I go? Like when I drew this part of the graph right here, was I really thinking hard about, well, okay, I should go just a little bit, go way down. And I'll talk about this a little bit more in the next problem, but I'll just give you a little bit of a quick rule of thumb. If the intercepts are packed kind of close together, like separated by just 1, there's not enough room for there to be big, huge changes going on, big maxes or big mins, and you'll see that in a second. When there's more space than 1, then you got to think about what you're doing and maybe do a little bit of evaluating for some extra coordinates. But this is a pretty accurate graph for the most part. Okay, let's try a couple more. And we're really just going to keep doing the same thing. The only difference in this problem compared to the other one is now I'm going to have to do some factoring. Okay, so there's the factoring part of it, just kind of your standard stuff. From my factors come my zeros. This one actually produces a 0 that is 0. That would be 4, that would be negative 3. Now, one thing to kind of keep in mind, right, is that if you have this as an x-intercept, you automatically have this as a y-intercept. That's has to be, right? There's no way around that, that's for sure. Or if I said plug in x is 0 into the original function, well, you get 0 for y too. Now, in terms of end behavior, it is negative and odd. And negative and odd means you are going to fall right and you're going to rise left. But again, you guys should kind of just know that this is negative and odd, right? So yeah, I got a set of rules, but I kind of really should know what the behavior is going to be anyway. Any zeros with even multiplicity. And when we say it as zeros, we're actually saying, like, does the 0 show up more than once in the list? Which it doesn't. It's the same as saying, what's the exponent on each factor? Well, they all have exponent 1, so this is a no. Extrema, 1 less than the degree, so it's degree 3, 2 changes in direction. Now, once again, I'm going to go ahead and get things plotted and see what I've got going on here. So, intercepts. And behavior. Well, if you think about behavior, it says it's going to fall right and rise left. Now, here's the thing about this, right? Let's say you just assume you're good to go, and you start drawing the graph. How do you know what it does in here? It literally can do any of those things, and you don't really know by just plotting the x and y intercepts. So what you have to do is you have to do some additional points, which means you got to evaluate at some of those spots that are in between your intercepts. There's a lot of space there. You have 2 spaces on one side, 3 on the other. You literally could evaluate like 5 points to get a really super accurate graph. But you do have to evaluate. So what do I do? Well, I'm going to do like the f of -2, the f of -1, the f of 1, the f of 2, the f of 3. All those things that are available between my intercepts and generate some coordinates. So we're going to go ahead and do some evaluating. Now, evaluating is just as simple as, and actually I'm not going to spend time to do the work, I'm just going to write down the answers here. But all you got to do is take those x values and plug them into the original function. Let me just jot some down for you. So let's say we're going left to right. F of negative 2 is negative 12. This would be plugging into the original function. F of negative 1 is negative 10. F of 1 is 12. F of 2 is 20. And the F of 3 is 18. Now, we get all those just by going back to my original function up here and just plugging in. Or I guess the P of, right? It was the P for our original function, but that's not that big a deal. Now, what you're going to notice as you start to plot these is it wouldn't occur to you to put these points where they are, just like randomly on your own. You wouldn't do that. So think about some of the coordinates that I'm going to put down. So negative 1, negative 10. Negative 2, negative 12. 112. 220. 318. So the idea is you got to do some, do you have to do that many? Probably not, right? You could probably do maybe 1 in the one section, maybe 2 in the other, not all 5. But there's no way you're going to draw it like that, just on your own, just like randomly, ooh, look at how high it goes. This is not going to happen, right? So now these additional points are going to tell you for sure what's going on. Okay, so if you have space, and I'd say any more space than 1, I would check the x value in between, plug it into the function, and give myself another coordinate, give yourself a more accurate graph. All right, one more to go and wrap it up here. So we want to see the multiplicity deal, like when does it actually take effect? Because so far it's been no to both the questions. So we're going to start out by get it factored. Now this time what I may do is skip right down the zeros and just see if we can go from factors to intercepts. Which would also produce a y-intercept. Then we'd have 2, and we'd have 1. In behavior, we're positive and even. That's up and up. Any even multiplicity? Yes. X squared. Which means at 0, 0, you're going to have the bounce. Extremo, 1 less than the degree, so we've got a degree of 4, so we'd expect 3 changes in direction. Now, let's go ahead and put those points on. 0, 1, and 2. And they're all packed in really tight, which means there isn't a lot of space for any big fluctuations, any big max and min changes. So I'm not too concerned about additional points. But here's the thing about the bounce. If you don't catch it, what the behavior says is it should go up and up. Let's say doesn't occur to you there's a bounce, you missed that part of the problem, and you start trying to draw this. And you're just going to start going through and you're going, okay, change direction, and wait a minute. Right now you have a conflict, what you're drawing and what the behavior is saying is supposed to happen. And the reason it's happening, like the conflict, is because you didn't catch the multiplicity. Right? So what's supposed to happen is this. When you come in, let's get these guys out of here too. To the intercept that has even multiplicity, what should happen is the graph is going to come to that spot. It's going to change direction right at it. And bounce, which means it does not pass through the x-axis, it just like deflects off that point. And then you got your max and min, which are kind of subtle. Now, how I do the max and min there, as far as the size of my, doing this part right in here, this part right up here, that's kind of a little bit random. I just know they're not big changes, so that's going to be close enough for my sketch. Okay, that should be enough to get you going on a good solid list of stuff that gives you a pretty accurate graph and all done by hand, no calculator. That's it for 3.1.